Hello, my name is Catherine Katsaforos, and I will be teaching the visual part of this course. We will be using Photoshop CS5 and GIMP, both of which are applications for creating and manipulating digital images. GIMP is a free open-source solution offering the same functionality as Photoshop, which is proprietary and belongs to the Adobe Creative Suite of products. Before we get to learn the software, we will first look at what digital images are, and we will familiarize ourselves with some parameters used to define and describe them. So let's get started. First, it's important to understand that a digital image is a two-dimensional numeric representation of an image. An image could be a vector or a raster file. In this course, we will be working with raster images, which is how Photoshop and GIMP see images. A raster image is essentially a grid of pixels arranged in rows and columns. A pixel, a picture element, is the smallest controllable element of a digital image. In other words, a pixel is the smallest part of your image that can be assigned a color value. When all of the pixels are arranged in rows and columns, they make up the image you see on screen. By zooming into an image enough, you will be able to identify the discrete pixels comprising the image. Now, let's look at two primary color modes we use when working with digital images. RGB stands for red, green, and blue, which are the primary additive colors. Additive color is based on transmitted light, which is how your monitor works. In RGB images, each pixel has a little bit of red, a little bit of green, and a little bit of blue. 1 byte of information stores the value for each of the colors, red, green, and blue, in each pixel. So there's a total of 3 bytes determining the color of each pixel in RGB images. Each byte can store 256 discrete values between 0 and 255, which is referred to as the digital value scale. It's like 3 stage lights that can be controlled in increments between 0 and 255. When you assign a pixel the maximum color value, 255, for each of the red, green, and blue channels, the resulting pixel will be white. If you assign a pixel the minimum color value, 0, for each of the red, green, and blue channels, the resulting pixel will be black. Now, before we go any further, you will have to take a brief quiz on the information we've covered so far. CMYK. Subtractive color is the model used by a printing press, and also painting with pigment. Cyan, magenta, and yellow are the primary colors, and when mixed they give you a dark gray because subtractive color is reflected and not transmitted light. Therefore, for a true black, there is a fourth screen added in printing, K, which is black. The amounts of each primary and block colors are expressed in percentages. These two color models are used for different purposes. RGB is used for the web and for the screen generally, and CMYK is used in printing. Since we will be working with digital images that will primarily live on screen, we will be working with RGB images. Computers speak binary, which is limited to the numbers 0 and 1. Information is stored digitally in a computer with sequences of zeros and ones. Each digit, a 0 or a 1, is called a bit. Groups of 8 bits in a row make up a byte. We talked about RGB images and how each of the colors needs 1 byte dedicated to it. We also talked about how a single byte can store 256 unique color values. Let's see where this number comes from. Each of the bits of a byte can be a 0 or a 1. That's 2 passable values for each of the 8 digits of a byte. This makes 2 to the 8th power possible combinations or values. If you calculate this number, 2 to the 8th, you will get 256. Because 1 byte is assigned to each color channel, and that is actually 8 bits, if we multiply 8 bits by 3, the number of channels in RGB, we will get 24. So one way of referring to our RGB images is 24-bit RGB. This level of color depth results in millions of colors. It is possible to have more than 8 bits assigned to each of the colors for RGB images in some systems, but that is beyond what we need for this class and beyond the needs of a lot of image-based practices at the present time.